Hi folks, we're going to take a look at the last question on the Unit 7 quiz. So here we've got a particle is moving along this given parabola when the x component of the position is 4, its y component is increasing at 2 units per second. Determine how the x component is changing with respect to time at that moment. Okay, so hopefully you recognize this as a related rates question. Okay. They give you the rate of change of the y component, so the y component, okay, and we want to find the rate of change of the x component. And in this case here, the relationship between the x and y components is just given by the equation of this parabola. So sometimes it might be given by some kind of measurement formula, it might be given, say, in terms of Pythagoras. Here, they're explicitly giving you the relationship between x and y. Okay. Now, what I would do in a question like this, just to kind of really set it up well, I often talk about the diagram being very useful in setting up a problem like this. So I know that this is a parabola opening upwards, okay? And I'd like to know where this x component of 4 relates to the parabola. So I can find the minimum of this parabola, okay? So we know that the x value of the vertex, okay, you can either take the derivative or use your old negative b over 2a. So let's say I use that, so negative b, negative 4 is 4 over 2 times 1 is equal to 2. So I know the x value of the vertex occurs at 2, so that means x equals 4 will be beyond that. And if I want to take a look at whether this is above or crosses the x-axis, well, we can just check the discriminant of this right-hand side. So if you do negative b squared minus 4ac, so negative 4 squared minus 4 times 1 times 5, okay, and that's equal to 16 minus 20, which is less than 0. So you see how we use these little tricks to be able to set up our diagram quite nicely, okay? So here I know that my minimum occurs at x equals 2, and I know that this parabola is strictly above the x-axis. Okay, I don't even really care what the minimum is, but it just allows me to draw my picture a little more nicely. Okay, and what we're interested in is the rate of change of the x component at x equals 4, but I'm going to worry about that later on. So even before I start, okay, they kind of gave me a little hint that the value 4 was going to be after the vertex because they say the y component is increasing at a rate of 2 units per second. If it was to the left of the vertex, it would be decreasing at a particular rate. Okay. Now, since the particle is moving from left to right, the x component's rate of change should always be positive because I'm moving from left to right. So these are all little things that are going on in the back of my mind, so I get a sense of where my answer should be heading. So I should be getting some positive rate of change. Let's now find the solution here. Okay, so we need a way to relate x and y. I actually don't need to find it here. It's given to me straight away. This is the equation that relates the x and y components. Okay, where you have to be careful in this question is we're looking at the derivative with respect to time. Here they're telling us how y is changing with respect to time. So I'm not going to be taking dy dx here. I'm going to be taking dy dt. Okay, and so I'm going to have to do the same thing on the other side, which is really what I want to do since I'm looking for how the x component changes with respect to time. So when I take the derivative here with respect to time, well, I've got a subtraction addition. So let me first take the derivative of x squared with respect to t. So I need to use the chain rule. First I take the derivative of x squared with respect to x, which is 2x. Then I multiply that by the derivative of x with respect to t. Same thing here. First I take the derivative of negative 4x with respect to x, which is negative 4, times the derivative of x with respect to t. And then here, the derivative of a constant, regardless of the variable of differentiation, will always be 0. Okay? And so now I've got my equation that relates the rates of y and x with respect to time. Let me plug in what I know. So I'm told that dy dt is 2 units per second. Okay. Here we've got the specific moment at which we want the rate of change. So x is equal to 4, so 2 times 4. Okay. In this step, I might as well factor out the dx dt. Okay, so here I've got minus 4, and then dx dt on the outside. And so here 2 equals 8 minus 4 is 4. So the way the x component is changing with respect to time would be 1/2 units per second. Okay? And there we go. We have it. Now, think about this here, how a parabola increases. I think it makes sense that the y component is increasing more quickly than the x component. Okay? Given that the you can even think about the concavity being positive here. Okay, that the y component is increasing more quickly than the x component is. Okay, so just to recap, because this, slightly different looking problem than what we've seen, but we're using all the same tools. So first of all, set up your diagram. Here we use some function knowledge to draw ourselves an accurate diagram. Okay. We're already given the relationship between the two variables. From there, it was taking the proper derivative. In this case here, taking the derivative with respect to time of both sides of the equation. And we had enough information to solve for what we were looking for. Okay, that is it for this one here.